Hey, welcome to my channel. Today I'm just going to talk about something a little bit technical, actually. Something that I've been meaning to talk about a little bit, but I'm just going to give a quick high overview. I'm not going to get too in detail about it. If you want to know more, please let me know in the comment section, and I will create another video that will probably be a little bit longer, discussing more about the topic in hand, which is basically vector databases. I created a quick PowerPoint or slide deck very quickly to describe it on like I said, a quick overview basically of it, more than anything else. Get to it right now. So vector databases. So basically you can ask like, what is a vector database? So vector databases are like a new type of database that are designed to store and search for databases or data actually that is represented as vectors. Now, you might be asking, what the hell are vectors? Vectors are kind of a mathematical way of representing data as a list of numbers. This makes it possible to store and search for data in a way that is much more efficient than traditional databases. And when I'm talking about traditional databases, we're talking about like relational databases and such. These databases, like Oracle, SQL Server, Postgres, MySQL, and such, it's think about the vectors themselves as kind of mathematical objects that represent a point in high dimensional spaces. Now, each dimension of a vector represents a different attribute of the data. So let's say, for example, a vector for a document might have a dimension for the document's title, author, date, and content. It's something that, you can basically use that traditional databases, RDBMSs, or even NoSQL databases for that matter, the main ones like Mongo and such, are not best suited for, like text, images, and audio, even though they are, but not in a ways that the way it's being used right now. And I was telling you what a vector database was, of course, yes. So one of the things is okay, why would you even use a database? Like, what vector database? Like, what's the purpose of it? What are some use cases? Is what I should say, basically. Now, again, as I mentioned, basically they're suited for well suited actually for storing and querying large amounts of unstructured data. Now you might be asking, like, well, why not just use a MongoDB or Cassandra for that matter? Well, this unstructured data, first off, for those that don't know what an unstructured data is basically unstructured data is like, it doesn't have a predefined schema. So when I talked about title, author, and date, that's kind of like attributes. Now think about stuff where like you have a document with multiple titles, multiple authors, and multiple contents that don't fit that norm. And images, for that matter, they don't have any structured data involved in there. They're mostly unstructured, same as audio files. So this is where like these vector databases would make more sense, and you actually it gets converted into bits that get stored in there, and you could search through them essentially. Whereas a MongoDB, that's more well suited for content management systems more than anything else. So the vector databases can be used for a variety of tasks, right? I mean, some of the use cases are, in this case, content search. Now, content search vector databases can be used to search for content based on its contents, such as text, images, or audio, of course, as I mentioned. Within this factor, I mean, in this case, like the text search can be used for text documents that are similar to a given query. It's used for tasks that are finding relevant articles on a topic or finding similar products. Image searches themselves, basically, a vector database can be used to search for images that are similar to a given query. This is useful for tasks such as finding similar photos or finding images of a particular object. Now, audio search is another aspect where you can see that as searching through audio files for a specific query, where like songs or similar songs or particular recordings of a particular person or people, basically, or certain phrases. That's where vector databases come in handy at that point as well too. Now, it also comes down to a point of like, great for using for recommendation systems. Uh, to basically like recommend products, services, or content to users based on their past behaviors, like your whole uh, Netflix aspect of what you should be recommended to watch, and all these other things like Hulu Live and such. They recommend based on your viewing history, they'll recommend you stuff. And same thing with Amazon, your reading history and such. That's where they play a factor into that, and that's where vector databases come into play. Now, under that aspect of recommendation systems, you got the natural language processing, where you would store and search for text data such as documents, emails, social media, posts, and such, and then you're doing a little bit of sentient analysis, topic modeling, and question answering at that point. So those are more of a case where, like, in this situation, that's where the recommendation comes in based on all that stuff that you've been asking about, and it plays into factor at that. Well, it plays into a factor for that. And then, of course, vector databases really work well in machine learning. It can be used to train and deploy machine learning models. This is useful for again, image classification, object detection, and speech recognition. It's fairly something that more or less people have been using lately, as of late. Right now, you're starting to see a much more gearing towards graph databases than vector databases. It's a hybrid of both, basically. It's that people are starting to use at this point as well too. Now, what are the pros and cons, of course? So some of the pros, of course, here, as you see here, is like you got the high performance aspect, where vector databases can perform queries on large amounts of data very quickly. Sorry. From that, you'll have, a faster search, and, especially for large data sets. Definitely for scalability, where it can be scaled to handle very large data sets, of course. I mean, it's one of those things where more often than not, large data sets are set from that perspective. And this is where you got audio and images, basically, specifically large images, but more of large audio and video for that matter too. And then, of course, there's the flexibility where it can be used for a variety of tasks, as we mentioned earlier, basically, where for like such aspects of like, actually I don't know an example of for the flexibility aspect of things, because it's like more of a case where like you're using it to search through documents or through images or moreover through video for a particular scene or a particular phrase that was used in a movie, and finding out who said that phrase in the movie itself, basically. Now, of course, you got the cons too, which is the complexity part of it, where it can be more complex than more traditional databases. Does not fall into the line of relational databases. It's very much more complex. And the other aspect as well too is it is definitely not suited for all data types, because in the vector by vectors, especially structured data, it doesn't play well. Quite honestly, performance is not as great as you would think it would be. If you have relational structured data, that's where you use like relational databases and such. And of course, you've got the cost aspect as well too. It's not as cheap as you'd think it'd be. It's one of those things where it can be more expensive than very traditional databases as well too. And of course, then there's the other aspect of the limited support part. It is relatively new. Graph databases have been around a little bit more, so vector databases started coming about as well too. So you're starting to see more. The graph database was more used in the aspects of social media more than anything else, and vector databases started to become more and more prevalent as a result of some of the stuff that was coming out with some of the machine learning models that graph databases couldn't entirely support. So those are some quick pros and cons for that. Now, some vector databases that are out there right now, basically, I mean, I haven't worked with some of these, to be quite honest, but Milvus is definitely an open source vector database that's designed for high performance for vector search. Pinecone is basically, it's managed, but it's built on top of Milvus, basically. So it's a managed vector database that's built on top of Milvus. If anything, I would, and it's more cloud native. It's more cloud based more than anything else. Face, of course, is a library for efficient and similarity of search of dense vectors. dense vectors are more of a case where you have a lot more larger attributes with a lot more dimensionalities that are tightly coupled together at that point. And then of course you got Annoy, which is, it's fast, scalable, and approximates the nearest neighbor search library. In that aspect, it's more of a case of like how close of the dimensional space is. Like if you got higher dimensional spaces, this is where Annoy comes into play. And then of course you got HNSW, which I've never worked with as well too. It's navigable small world graph for approximate near neighbor search. That's actually, I'm sorry, that one I actually had to go in and basically look what it was exactly, because I've never heard of it. But it's relatively new in certain cases. But quite honestly, it's something I've never personally worked with. I'm just getting into it as well too, to be quite honest with you. It's something I would love to collaborate with and work with others, or others that want to know more about it as well too, or others that are experts in the field. I would love to talk to them and ask them more questions. I'm only basing my stuff on the stuff that I'm reading right now and stuff that I've kind of tinkered with a little bit with Milvus for that matter. It'd be great to talk to others as well with it. But with that, if I'll leave it at that. You're welcome to leave me any comments in the comment section. I do read them, of course. If you would like more information about this, I will probably go more in depth as I do more and more research into this, considering that, and I'll probably do another video about graph databases as well too. But if you have any recommendations or requests for more information or such, please leave me in the comment section. As well as I will say this: there is some pretty good documentation out there on vector databases, specifically on Microsoft site as well as on Pinecone sites as well. And there are some others that have put some information out there as well too. And of course, if you do enjoy my content, enjoy some of my videos, and enjoy my channel, and if you haven't subscribed, I do ask if you subscribe. I will start posting up a little bit more videos about the technical nature more than anything else. You've seen me talking more about lately more about sports. I mean, I'm a New Yorker, so talking about sports related stuff like with the Knicks, Giants, and the Mets, of course, and the Islanders. So more often, I will try to gear towards the tech side of things now a little bit more. Granted, the fact that the Mets are losing, so that's probably the reason why I'm gearing more towards the tech side of things. Also, the other aspect is you also were seeing me talking a little bit about some of the reality shows and such, and some of the TV shows. I was just delving into that. I'm no expert in those, but I do know technology. I'm no expert, but I do know it, specifically in tech stacks, basically what to use for some of the use cases. Eventually, I probably will create a demo type of thing for some of these stuff I'll be doing, and from there, I'll just leave it at that. Again, if you have any questions or feedback about this topic or any other topic you want to talk about, please leave it in the comment section. I'll talk more about it. With that, I'll leave it at that. Unfiltered, unedited, and unrehearsed. Until next time.